Our next speaker is Ixchel Meza. She has a master's degree in data science by ITAM and is an expert in CONABIO's Office for Interinstitutional Projects, where she collaborates in the monitoring activity data for Mexican reducing emissions from deforestation and forest degradation. It's called Plus Red program and is a part of the global efforts to mitigate climate change. She will be presenting us today an use case for AI environment monitoring and protection. Welcome, Ixchel.
Creo que tienes que apuntar muy bien hacia allá.
¿Hacia dónde?
Hacia la
¿Hacia allá? Okay. Okay, I'm going to do a test. Yeah. Okay, I'm going to talk about MadMex that was already introduced, but first I'm going to say I'm going to talk about CONABIO. For those of you that don't know CONABIO, CONABIO is the Mexican Commission for the Knowledge and Use of Biodiversity. And among its missions are to promote the knowledge of biodiversity and also the conservation led by local communities and a sustainable use of biodiversity. It was founded, this commission, as an applied research institution. That means that all the research that is done there, it's applied. It's not just it is not it doesn't die on a paper. And one of the things of CONABIO is that it has implemented some AI algorithms in some of its duties. For example, to classify animals out of images, or to do semantic segmentation on bats audio to detect bats species, and also to do land cover and land cover classification of the entire country. And that is the goal of MadMex. Now, before I talk about MadMex, I'm going to say some information about Mexico to have some context. Mexico is a large country. It's the 14th largest country in the world. It is almost 2 million square kilometers. That means if you think about that in pixels, that has that represents between 5 and 30 meters length. We are talking about 2 billion pixels, or well, billions of pixels, right? Another thing is that Mexico is one of 10 mega diverse countries in the world, and has the most ecoregions in Latin America. That means that the land cover classification is not a trivial problem at all, because of the complexity of the land. And one more thing is that around a third of the country is covered by forest. And one thing I didn't know, more than a half of natural vegetation is degraded. That means that it has changed because, I don't know, many reasons. Main causes are because forest degradation and deforestation, which leads to a need for information for decision makers involved, among others, in territorial management, urban growth management, and public policies regarding forestry and agricultural sector. another thing I want to say is that Mexico has a commitment to develop a monitoring system for Mexican RED program that are strategies that seek to reduce emissions from deforestation and forest degradation in developing countries. So because we had this commitment, CONABIO, CONAFOR, and INEGI started a collaboration in order to tackle this commitment. And until then, INEGI did classifications, but the time between those classifications was between 3 and 10 years. So that is not really good for monitoring sake. And well, they did a really thoroughly classification with almost 220 classes. And these classifications, called INEGI series, are very expensive. So it was not a really good idea to use them for our purpose. So, it was. This system called MATMEX is a geospatial information system for national land cover classification using machine learning algorithms and satellite imagery. The satellite's image resolution are of 30 meters, 10 meters, and 5 meters. It can process different kind of satellite images from different sensors with different spectral bands. And we use unsupervised learning and supervised learning. Unsupervised learning to do segmentation of the land, of the country, because it's quite huge, and it's based on similarity in the spectral signatures. And supervised learning, like random forest and XGBoost. Someone asked me why you don't use deep learning. Well, to process that, it is not that easy to process that amount of information. And because we're talking about terabytes of data, no? And that's why the geospatial data management is really crucial for this purpose, and we are doing it with the Open Data Cube. And I also want to talk about the difficulties to process this kind of data. For instance, we have unbalanced data sets. We have in the ratio of 1 to hundreds. And we don't have enough training data for some of these classes. Also, the availability and quality of input data changes because of weather conditions. For example, this year, we had a really with high temperatures, not so many rain, and all those things changes the spectral signatures of the images. So the algorithm's performance changes and varies because of that. Also, the images could present clouds or fog, and these clouds could means shadows on the land, and that also impacts the performance of the algorithms. Also, artifacts, noise. For example, the satellite Landsat 7. Its images present stripes, a lot of stripes because of some defects on the sensor. And also, I forgot to mention. I forgot to mention the interpreters, because interpreters verify classifications in order to validate. Well, we use a dataset made by them to validate. So it's really complicated. And here is an image, for example. This is one tile of a satellite, and if you can see, the sun on the north changes its colors throughout the year. These are images of the same place during a year, and there are clouds, there are the shadows, the changes of the colors, and all those things. And well, this is the example. This is example classification, and yeah, this is a land cover product we made. This was done with Sentinel-2 imagery of 10 meters resolution, and the whole thing has more than 200 million polygons classified, 31 classes. It represents 1 year, and it's more than 100 times cheaper than an INEGI series. So I think that's really good. And I want to finish with saying two things. First of all, I mean, of course, there are inaccuracies, and I don't hear that too often. But there are inaccuracies, and I think we have to repeat that again and again to the final users, because there are sometimes that they see, I don't know, some area of Mexico, and they see, I don't know, maybe 20, 30 polygons that are misclassified, and they want to throw the whole thing to the garbage. And that, I mean, if you think that there are more than 200 million polygons, of course you're going to find misclassification. So I think it's really important to repeat that and to keep that in mind, because yeah, there are errors, but if you use the product, having that in mind can be very, very valuable. And the other thing is that these kind of projects are not that common around the world. I know about some countries, I don't remember which ones, but they are trying to do the same things, and there are other countries that don't have this kind of products, but they want to have them. So that's it. Thank you.